All right, everybody, so this is the multiplicity homework, the parts underneath the notes from today. So the first part says determine the degree of the polynomial, then state the zeros of the functions and their multiplicities, then determine what the graph would do at each x-intercept. No calculators. So how would you do a question like this? First, identify all the zeros. So that's identifying all the factors. We have x plus 2, and we have x minus 5. If you would set each of those equal to 0, it would tell you exactly what the zeros are. So from here, we can see that the zeros are 0, -2, and +5. Each of their multiplicities is stated by what degree they're raised to. So in this case, the first power on x, so it would have a multiplicity of 1. X plus 2 is raised to the third power, so it has a multiplicity of 3. And then x minus 5 is to the fourth power, which has a multiplicity of 4. So what is happening here is that odd multiplicities always cross, and then even multiplicities always bounce. The degree of this function is how many x's are we talking about here. So this is technically an x to the fourth power. This would be an x to the third power. This would be x to the first power. So 4 plus 3 is 7, plus 1 makes this an 8th degree polynomial. All right, so for number 2, following the same thing. This -2 out front, that's just the leading coefficient, not too concerned about it. But all of our factors are x minus 3, x plus 1, x minus 1. So the zeros are 3, -1, +1. -3 has a multiplicity of 1. X plus 1, which would be this -1, has a multiplicity of 3. And x minus 1 has a multiplicity of 2. So again, odds multiplicities always cross. Even multiplicities are always going to bounce. The degree would be 2 plus 3, which would be 5, plus 1 is 6. So this is a 6th degree polynomial. So you can really just add up all of the exponents, and that'll tell you what the degree of the polynomial is. So it says, given the graph, answer the following questions. Is this even or odd? So we first look at the ends. Even ends always go in the same direction. These are going in different directions. So this tells us this is an odd function. Is the leading coefficient positive or negative? So how do we tell that? We think about our most basic odd function. In this case, y equals x is the most basic odd function. How does that look like going through a graph? Well, it goes just like this through a graph, right? So we have an end that's going negative, negative. We have an end that's going positive, positive. In this case, that's not what's happening at the ends. They're in two different quadrants. So what we're doing is we flipped our most basic odd function. This one looks like the line y equals -x, something like this at the ends, right? So this has a negative leading coefficient. The zeros with their multiplicities, so we have a 0, -1, so x equals -1. We have a 0 at +3, so x equals 3. The multiplicity at -1, it bounces, so this is going to be even. It looks like it's second. Okay, it's a 2. Looks like it has a 2 for its multiplicity. Over here, it's an odd multiplicity, and it looks like it's 1 because it's just going straight through that point. There's no kind of cubic function going through there. So just odd and 1. So the following graph has zeros at x equals 2 and x equals -3. So here's our x equals -3. Here would be our x equals 2. One has a multiplicity of 1. The other has a multiplicity. The other's multiplicity is 3. Determine which one each must be. Oh. yeah. So it's asking which one has which multiplicity. Because we're going straight through at x equals -3, x equals -3 must have a multiplicity of 1. So mult 1. X equals 2, notice how this looks like a cubic function, okay? So if we took this, x minus 2, raised it to the third power, it's going to look like a cubic function coming up through here. Okay, so this one, x equals 2, must have that multiplicity of 3. All right. And on to the last one here. It says answer the following questions about the function, then sketch the graph. So first it's asking us for the degree. Again, we can add up all of the exponents. So first, second, and first. So 1, 2, 3, 4, fourth degree polynomial. Leading coefficient in this case is positive. Okay, I only care if it's positive or negative. I don't care about the number that much. End behavior in this one, so it's fourth degree. It's a fourth degree positive, so as x goes to infinity, or goes to the right, f of x is going to positive infinity. How do we know that? Because the most basic even function is y equals x squared. And because it's positive, it's opening up. So as x goes to the right, f of x goes up. And then as x goes to negative infinity, f of x is still going to positive infinity. What are the x-intercepts with their multiplicities? So the x-intercept are 7 with a multiplicity of 1. We have x equals negative 1 with a multiplicity of 2. And we have x equals positive 1 with a multiplicity of 1 as well. So we need to go positive 7, 1, 2, 3, 4, 5, 6, 7. Point there. We need to go negative 1 with a point there, and then positive 1 with a point there. What is the y-intercept? To find the y-intercept, you can plug in 0, or you can write it out completely, x minus 7, x plus 1, x plus 1, x minus 1, and multiply all of these together. So that's negative 7 times 1 is negative 7, times 1 is negative 7, times negative 1 is positive 7. So we have 0, comma, positive 7. So we go 1, 2, 3, 4, 5, 6, 7, puts us right here. And then our end behavior is opening up like this. So our graph is going to look something like this. Do we bounce at that first one? Yeah, negative 1 has a multiplicity of 2. So we bounce, come back up, and then we go through, because there's a multiplicity of 1, and then we come back up through. All right? So, kind of weird looking, but that's what the graph would look like for all that information that we found. All right, number 6. The degree of this one is third degree, just the highest degree. Because it's not in factored form, we can just look at the highest degree to tell us the degree. Leading coefficient is positive, and you actually know that it's 9 in this case, but we only care about positive. So third and positive means it's going to look like y equals x. Y equals x is up and to the right, down and to the left. So as x goes towards positive infinity, f of x is going towards positive infinity. As x goes towards negative infinity, f of x is also going towards negative infinity. So then the x-intercepts / the multiplicity, in order to find those, we need to do some factoring. So you can factor out the x. So when you factor out x, it's going to give you 9x squared plus 6x minus 3. So it's going to give us x. We have 3x and 3x. We have negative 3. So that's going to be, if we went positive 3 would give us 9, negative 1 would give us 9 minus 3, which would give us positive 6. So x equals 0, x equals, that is 1/3, and x equals 3x plus 3. I guess we could have pulled a 3x out of there. That's going to be x equals negative 1. All of them have a multiplicity of 1. So then we need to find the y-intercept. In this case, if you plug 0 into this equation, each of them would just become 0. So 0, 0 is the y-intercept. So 0, 0, we have a point at positive 1/3 and negative 1. So I'm just going to spread this out a little bit. So negative 1 is this point. Positive 1/3 puts us here. And then we need to be down. So we're going to start graphing this from the bottom here. We're going to come through the origin and then back up through that 1/3 point. And that is what the graph would look like for number 6. If you guys have any more questions, please feel free to ask me. I hope this video helped just clear up any muddiness from today. All right, have a great day, guys.